Hey Stan, I wanted to go ahead and give you this lesson real quick so that you can get started on it after you get done with your test. This one's about our unit circle definitions. And so we're also going to be graphing some of our trig functions. And hopefully the first part of this will be kind of a review. I wanted to remind you from our unit circle that we had. We've already talked about the fact that the values of the first value, which is the x value, is going to represent the cosine of x. And then the second, well, the y value is going to be the sine, and why that was. But today we're gonna kind of go a little bit further. Remember that all of our cofunctions then would be the inverse of those, and we can find a point on the graph. So if I have this point where this is going to be my alpha, which is my angle, and this is my coordinate x comma y, then this is also going to be the sine of a comma the sine, or the cosine of a comma the sine of a. Um, when we did that, this is an example of the unit circle that we have that I've provided for you already. And then we filled out these with our special triangles. Remember, we have the 45, 45, and 90 right triangle, and also the 30, 30, 60, 90 right triangle, which creates these points. And these are kind of just special points that we'll continue referring back to. So it's a really good idea for you to use to know these, not only just in the degrees, but also the radians of each of those sine and cosine and tangent functions for each of those angles. So jumping on, just as a review, when we look at the exact value for each trigonometric function. So again, if I refer back to my unit circle and I have the sine of 45 degrees, remember 45 degrees is going to be also the same as pi over 4. And my coordinate at that point would be the square root of 2 over 2, comma the square root of 2 over 2, which means that my sine and my cosine are going to be the same. So in this case, this was actually going to be the square root of 2 over 2. We need to remember too that other quadrants are going to give us different values in terms of positive or negative. So let's go ahead and do the cosine of 2 pi over 3. Now, if you haven't memorized it, remember 2 pi over 3 is also the same as then the 120 degrees that we have. So at 120 degrees, we have the point negative 1/2 comma square root of 3 over 2. And since we're looking for the cosine, I know it's the very first one that I have. So the cosine of 2 pi over 3 would be then a negative 1/2. If I have the tangent of pi over 2, now tangent is going to be, remember, the same as the opposite over the adjacent, which would also be my y value divided by my x value. So in this case, if I'm looking for the tangent of pi over 2, and I know that this is going to be the same as my y over my x, which also is the same as my sine over my cosine. Okay, my y value for this one, remember, was going to be 1, but my x is going to be 0. And so this is going to be a case where we'd have an undefined position because you cannot have a number 0 on the bottom. Okay, and then I'm going to inverse function on this one. So the inverse of secant, remember, is going to be the 1 over the cosine of pi over 3. So what I would do on this one, I'd first find out what the cosine of pi over 3 was. So I'm going to go to cosine of pi over 3 is the 60-degree angle right here. And it's also going to be, since I'm looking for the cosine, it's going to be the 1/2. So really what I have is 1 over 1/2. And remember, we can say that we can take the numerator times the reciprocal denominator, which would be 1 times then 2 over 1, which would be then just 2. And since I'm looking at the degree of pi over 3, I know I'm a positive number for both of those. So on our trigonometric functions, we also want to think about our domain and our range for each of those. We're going to have different values. We're going to look at different types of graphs, and we're going to have the Cartesian, the rectangular, and the coordinate system. When I look at the graph of a function, one thing that I'd like to share with you on, so let me stop sharing and then share again. Is the what the sine actually looks like. So when I look at our sine functions before, and I know I showed this to you later, where we had the value of cosine and the sine as a period function. In other words, it keeps repeating. It's also considered a wave. And the sine and the cosine are sinusoid waves. And notice as the graph goes around, as it keeps repeating and rotating it, then we get another wave in our sine and cosine functions. And so when we graph this, I'm also going to have you look, when I have the first part, it's going to be looking at what happens to just the sine of x. So if I look at the sine of x, I'm going to have the point 0, comma 0, because I know that the sine of 0 is 0. But then I have a maximum point, and my maximum point is going to be at that pi over 2, or 90 degrees. And then I'm going to end up at the middle, or the inflection point is what they call it, is going to be where it crosses again. It's going to be, in this case, it's going to be pi, because I know I'm back to 0. And then this is going to be the 270, or 3 pi over 2, which I know that's a -1 is the sign. And then I can go back. And these are considered my 5 key points that we're going to talk about. And if you can find these 5 key points, most of the time you can easily graph most of your functions. I'm going to quickly change this and change it and let you look at the cosine function. My cosine function, I know at 0, my cosine is going to be 1. And then notice that it's still that same period function. These are my 5 critical points, but this time it's going to go down at pi over 2, the cosine is 0. At pi, it's -1. At 3 pi over 2 is 0. And then back at 2 pi, or 1 full rotation, it's going to be back to 1. And so that's 1 period. Let me go ahead and share back to my document. So when I look at this, we're going to sketch the graph of the sine, and we're going to go from the 0 to pi over 2. And so this is an example of my sinusoid function. And again, 1 period is where it changes. It starts off at one place and it gets to that next period. So it's, in other words, it's going to continue repeating this for infinity as far as you know. And this is also where you can get some of those values from our unit circle. So if you look at what happens at the sine when you have pi over 6, so in other words, if this is pi over 2, then my pi over 6 is going to be right about here. It was going to be about 1/2. And notice that's my y value. And then it's going to continue at pi over 3 is going to be square root of 3 over 2 until it gets to 1. And so each of those values then are reflected about our unit circle and what they are. And in this case, this is an example where my domain is going to be infinity to negative infinity to infinity, because there's no stopping it. It's going to go to infinitely to the left and infinitely to the right. But notice my range in this case. My range is really going to be affected right now, if it's a typical sine curve, just by the amplitude that we're going to talk about in a second. And so in this case, my lowest value is going to be -1, but my highest is going to be +1. Okay, an example, the definition of a periodic function is going to be y equals f of x is a function, and where the a is going to be a non-zero constant, such that f of x plus a for every x of the domain f is called the periodic function. And so keep in mind, when we start working some of these problems, we're going to have to identify some of these points. Okay. So the very first one, if I talk about the 5 key points of my graph of my sine function, I will start off with my starting point. Then I'm going to end up with my maximum point, my inflection point, my minimum point, and also my ending point. I could also have the same function and identify those same 5 points, key points of my y equals the cosine of x. But this time, at 0, 0, my cosine is going to be at a maximum, so that my starting point would actually be at 0, 1. And then as I go through, I'm going to have pi over 2. I'll have then pi, then 3 pi over 2, and then I'll go back to 2 pi, or 0. And notice on this one, the cosine of pi over 2 is going to be 0, and that would be then an inflection point. Then I'm going to go down at -1 for pi. And then at 3 pi over 2, I'm back to 0. And then I'm back to 1 at 2 pi. our functions are written very similar. If you kind of think back to what we did when we did parabolas and we did, our other equations. When I have a change within my function, that's going to be a shift left and right. This is going to be considered my amplitude. This is going to be how high and low my wave is going to go. B is going to represent a period shift. And then D is going to be where that midline right here will change. And so it's going to be a vertical shift then going up and down. So let's say that I have an example. Here's my example of what A equals the sine of B times X minus C plus D. And I have A is the amplitude, B is the period, C is the phase shift, and then D is going to be the midline. And this will also determine then my min and my maximum, which will be the same as my range. So let's start off with, I just have an example here. So if you look at this example, I'm going to start with my amplitude. So my A in my example is going to be 3. That means that for every wherever I had the 1, it's going to jump up to 3 more points. And I'm going to show this as what happens when we go to our Desmos. Share and Desmos. Okay, so on my amplitude, if I go ahead and let this be a 3, then you notice that and if I change this, let's just let this be my original parent, which is the sine of X. Okay, so I'm going to go ahead and show that this is going to be where it starts. But if I add 3 to this sine of X, then notice that it goes from pi over 2 comma 1 to pi over 2 comma 3. And then on the next one, I'm going to show that I have on my equation, I had of parentheses, then X, I had plus pi over 4. And then I'm going to also go plus 2. So in this case, you can see that the change of my graph represents this. The pi over 4 will represent the phase shift, and then also my midline. And notice that changes the minimum value and the maximum value of my points. So again, if I start on this one with having an amplitude of 3, but then my midline is 2, that means my maximum value is going to be 5, but my lowest value is going to be the -1. So it's going to be 3. Then my midline of 2, but then I'm going to go up 3 and down 3 to get my minimum range. Let's go back and look at the example that I had. So in this case, my amplitude is going to be 3. Then on the next one, on my period, which is the B, if you notice, I don't have anything here. So my period is just going to be 1. And notice that it done with your tests on chapter 1, but that's going to give you enough that you could get started, and over the weekend, you definitely can kind of get some of this done.